Hello dear students, in a previous class we were discussing about the phasor diagram. By taking some more problems we will get to know uh, the importance of phasor diagram. Through phasor diagram also we can solve the equation of particle executing the simple harmonic motion. That is also possible, but it is we can take it as it is one of the trick to solve the uh, equation of simple harmonic motion. But it is not to be utilized every time. We have to cross check with the same simple harmonic equation also. We have to cross check with the phasor diagram also, but phasor diagram will solve the equation very quickly. So once you were perfect in that, then only you can write. So I will we will go and discuss with both the part, so which is suitable for you, that you can utilize for solving the problems. So let us go ahead with the first problem. Particle executing the simple harmonic motion, right, with the angular momentum, amplitude and angular momentum omega here, and we need to find out the equation of a particle. So x we have to find out here. So directly I'm writing, no need to write all the whole equation or the whole problem here. So we need to find out the simple harmonic motion. We will solve it with a phasor diagram, that's it. This is of x, and this is of y, where t particle starts from, and I have forgot to mention here, particle executes a simple harmonic motion at t is equal to 0. A will be the amplitude, omega will be the angular displacement or the frequency is, where omega t will be the angular displacement. We need to find out the equation of a particle, right? It started from t is equal to 0 at this point, means phase angle is given, say about 30 degrees. That means phase angle is 30, means this phase is equal to 30 degrees. This means it is starting from here to here. It is here to here. Angle is a initial phase. Phi is what here? Initial phase. We have x is equal to a sine omega t plus phi, which is the general equation of a particle executing simple harmonic motion. And this phasor form of it, where it is executing the circular path, but circular path is not a simple harmonic motion. Its projection is a simple harmonic motion. It acts like a simple harmonic motion. It is right. Now we'll go ahead with the part here, where amplitude is given as a 2 centimeter and time period is given as a 8 seconds. Let us go ahead. So time period is given 8 seconds. Now we'll move on to the a sine omega t plus, what is that, phi is 30 degree. So directly you can make the measurement. So where it is moving from here to here at this point, t is equal to t, means this is the projection here. So directly I have written here. As you know the perfect manner of utilizing the phasor diagram, so no need to go ahead with the equation of simple harmonic motion and solving. It will take a much time. So better, once you use this phasor diagram, quickly you can solve it. Place the given value. What is that? A is equal to 2. So t is 8 second. We know the relation with that. Omega is equal to 2 pi by t, that is of 2 pi by 8. So 2 ones are 2 fours are pi by 4 it is. In place of omega, place it pi by 4 at t here, right? So plus of 30 degree. So this is of the final conclusion of equation of a particle executing the simple harmonic motion. Only this much it is. So once we can go ahead with the given, means initial phase at t is equal to 0, then here only it is begins if if the angle is given. But if angle is not given, how to find out the equation of a particle? So with the help of again clockwise. This is clockwise direction, the outlike direction of a momentum of particles, and one more form is their anti-clockwise direction, so that we will solve it. And when a certain type of question arises, that time we will discuss and we will solve in that part there. So until then we will prefer for only the clockwise direction, because it is very important as per the solution of a particle using the phasor diagram here. Now let us move on to the next problem. So where we need to find out the equation of a particle for simple harmonic motion when uh, it is said to be as a particle is executing simple harmonic simple harmonic motion, where A is the amplitude, omega is the angular frequency here, right? Find out the equation of a particle. So equation of a particle we need to find out in simple harmonic motion, right? In simple harmonic motion it is. So we need to make use of the phasor diagram here, where t is equal to 0, phi is the initial phase, right? So it is executing from and particle when particle executes the simple harmonic motion, A is the amplitude, omega is angular frequency. We need to find out the equation of particle simple harmonic motion when particle is moving in a positive direction. When particle is initially moving in a positive direction, where amplitude is given as a 2 centimeter and the time period is of 4 seconds. So let us go ahead with the 8 seconds. It is same problem, but it is moving in a positive direction. So positive direction means always it is in a clockwise direction. So it is moving in this direction. Otherwise you can take help of simple harmonic form here. So it is moving in a positive direction. It is from x is equal to 0. We don't know particle is at exactly this point or the particle is at this point where x is equal to a, wherever you can take. So particle is, it's moving from here means t will be 0 here, but the particle is moving at the positive direction. Initially it initially moving in a positive direction means it is moved from here, t will be 0, this position phi will be there, and again it is moving in a positive direction, this part. So always again it is moving in a positive direction. Say about it is moving this part, for example it is moving at this point. So draw the projection here, what you will get. So this part it is, right? So it is moving from here to here, it is moving from here to here. So this point and this point it is. So look at here, this complete part is a 90 degree, right? This complete form is a 90 degree. This is what here, angle. So this is what, omega t here. This is what, omega t. So this is of phi. It will becomes total 90 degree here, total 90 degree. So directly you can go ahead with the a sine omega t plus x is equal to a sine omega t plus phi. It is, as we move, particle is moving from here, distance is always measured from this point, whether it is moving from here, here or here, wherever it is in throughout circular form, always it is measured from beginning point. From here to here it is moving means up to this point it is 90 degree, correct? So up to this it is a 90 degree. I can say this is a pi by 2. So this is also called as a pi by 2, or else you can take a sine omega t plus 90. It is phi is 90. After this is omega t, because it is moving from t is equal to 0 to this point, but measurement is always from the beginning, x is equal to 0. So from here to here it is 90, and here to here it is omega t it is, right, where a is given to sine omega t. Omega t is what here, omega is equal to 2 pi by t, so 2 pi by 8, that is of again pi by 4, so pi by 4 it is into t plus 90. Look at here, sine 90 plus theta, sine 90 plus theta here. So 90 plus theta means in this 0, 90, 180, 270. So 90 and 270, allied angle is going to change sine to cos. So 90 plus theta, 90 plus theta, second quadrant sign is positive there, so but changes to cos, so pi by 4 t, and 2 is there here, 2 is there here. This is the equation of a particle executing the simple harmonic motion by using the phasor diagram solution here. So this is what, cos pi by 4. So I think camera is not cached here, so I'm going to write it here. X is equal to 2 sine pi by 4 t, 2 sine pi by 4 t. So because 2 sine pi by 4 plus 90 here, because 90 is a phasor from the initial phase where theta is what here, angle made, that is equal to omega t, angular displacement, right? So 90 plus theta, so 90 plus theta means second quadrant, in second quadrant sign is a positive, but allied angles changes to sine to cos here. So 2 cos omega pi, 2 cos pi by 4 t. So this is the solution for the this problem it is. So we'll solve one more problem with both the methods. Then we will get the conclusion that which method is a very utensilious and very easy method, but it should be perfect in manner. That's only. So particle executes simple harmonic motion initially at x is equal to plus a by 2, and again initially it is moving in it is moving in a positive x direction, Find the equation of a particle. Now we'll solve it first with the standard, that is a sine omega t plus phi. Means this, what is this? This is the displacement of a particle where the particle executing the simple harmonic motion. So let us go ahead with the diagram. Always you have to be perfect with the diagram. I mean, solve the problem with the diagrammatically. We know almost solution is only half part, it is completed by solving the diagram here, right? So initially, look at the particle execute the simple harmonic motion. Initially x is equal to a by 2, means it is x is not at the, or a particle is not at the mean position. Particle is at the x is equal to a by 2. Right now particle is there at the x is equal to a by 2 plus it is. So I have taken it as a positive extreme direction. and initially it is moving in a positive x direction, means it has a possibility to move towards this direction or this direction, but in this part positive only it is, because it is with respect to the mean position, this is a positive extreme positions direction. So it may move in this direction or it may move in this direction. Both the possibilities are there. But moving in a x direction, find the equation of a particle here. So placing x is equal to a by 2 here, what we will get? Let us go ahead. A by 2 is equal to a of sine omega t plus phi here. A get cancels, remains with 1 by 2 sine omega t plus phi. So look at here. When particle is moving from this position at a by 2, so this point a at t is equal to 0 it is. Means where it is begins. Earlier, or we may say that particle is moving from mean position. At that time t is equal to 0 here. But this condition, the given equation, it is not compulsory. It has to move from mean position only. It may move from negative, it may move from positive. But right now the given equation, particle is not at the mean position, particle is at the a by 2. From that it is executing the simple harmonic motion. So at that time period we'll take it as the t is equal to 0. Then what will happen here? So it is of sine phi is equal to 1 by 2. That means phi is equal to sine inverse of 1 by 2, means that is of 30 degree. So we got phi is equal to 30 degree here. So that is phi is equal to 30 degree. But particle's motion cannot explain by its displacement. When particle is under the motion, it does not change the displacement. It cannot be explains how the displacement is taking place. It's moving. Moving means just a moving it is. It's not showing the displacement. But displacement of particles explained by its velocity. Where how much velocity is there, in which direction it is moving. That's why velocity is a vector quantity. So we'll go ahead with the velocity of this particle. As we know, d by derivative of this equation, that is a dx by dt, that is of, what is that, a cos omega t plus phi of omega here, that we know v is equal to a omega cos omega t plus phi it is, right? Now at t is equal to 0, look at here, at t is equal to 0, velocity should be greater than 0. That means velocity is 0 always at the extreme position. Between extreme position and the mean position, velocity is greater than 0 only, because velocity is going to decrease when it is moving towards the extreme position. It should be here, it should be greater only. As it is moving, it is going to be 0. So in this condition, velocity should be greater than 0. That means velocity is not exactly 0 in between the extreme and the mean position, because it is moving, particle is moving. Moving means as it is moving, velocity is decreasing. This concept we know already from the previous class only. So that means what it indicates here, as v is equal to, at t is equal to 0, v should be greater than 0, right? So v is equal to what here, a omega cos phi, a omega cos phi should be greater than 0. This is the condition, should be greater than 0. That means this will be constant here, means amplitude and angular frequency, that cos phi should be greater than 0. So cos should be greater than 0 means when you go ahead with the allied angles here, all sine, tan, cos. When the cos will be positive here, either first quadrant or the last quadrant. But with the displacement, we got it here, phi is equal to 30 degree, that is a first quadrant here. So displacement is also first quadrant, positive is there, because body is moving in a positive direction. And its velocity is should be condition that greater than 0. Why means this I have explained. Velocity is 0 at extreme position, but body is not at the extreme position. Body is there at the in between extreme position here. That's why, but already it is in a positive direction. It should be in a positive form it is. Then cos is always a positive in a first quadrant and the last quadrant, but last quadrant phase is not positive. Sine is not positive here. That's why phi 30 degree is accepted it is for velocity as well as the displacement here. That means x is equal to what here? Final answer, a sine omega t plus phi. So phi is what here? A sine omega t plus pi by 6. 30 degree is nothing but the pi by 6. So this is the equation of a particle executing the simple harmonic motion by this method it is. Now with the same problem, I'm going to draw or I'm going to solve it with the phasor diagram. So final answer, I will not erase it. So let it be, keep it as it is only. We have to compare these answer with the phasor diagram, phasor method to solve the same problem it is. Now I'll go ahead with the phasor diagram here where it is assumed to be as a expressing, right? Now the particle is at this position. Y means x is equal to a by 2. It is positive direction, clockwise direction it is. So this is at the clockwise direction. At t is equal to 0 here. At t is equal to 0. That means, t is equal to 0 at this point it is. Where x is equal to 0 here, particle is there, this form, this part from here to here it is. So this is a positive direction. Here only you can imagine this is a negative extreme, this is positive extreme, this is the mean position. At t is equal to 0 here, it is moving in a positive direction. So it is moving in a positive direction. Let's take it the projection here. So this is the a. Radius we have taken a only, no? Now with the form here theta. So this is theta, this is the initial form, this is the initial phase phi here. So look at here, x is equal to a by 2 is there, right? Amplitude a is there here, radius is a here, right? Now theta is there here. So look at here, projection. So projection is there here. This we don't want only because this part is not needed. Projection with the diameter, this should be needed here. What is this? X is equal to a sine omega t plus phi. This is what? Omega t here. Omega t plus phi here, right? Now x is equal to a sine omega t plus phi here, right? And this part and this part, and this will be, if you want you can just cross check, a cos omega t plus phi it is. Look at here, this a is what here? A by 2. This is a. Opposite what? Yes, this is the general form of the equation here. Now let us find first theta. We don't know the theta value also, but it is moving in a positive direction. Let us find the theta first. A sine omega t. Omega t is nothing but the theta here. I will write it again. Theta, x is equal to a sine theta here, where x is given a by 2. Just place it here. A by 2 a of sine theta here. So a get cancels. So sine theta is equal to 1 by 2. So theta is equal to sine inverse of 1 by 2 is a 60 degree. Simplification I am doing, but as soon as you go through this point, a by 2 is there here. This is a is there, get cancels with the, mentally you can do it as it will happen with the practicing. So how much you will do the practice, that much quickly you will get the answer. But now I am solving to first attempt, it should be very clarified form. So A get cancels, remains with the sine inverse of 1 by 2, that is of 60 degree. That means we got theta is equal to 60. Now I will write it here. Theta is equal to 60 degree. Look at here. This form, this complete form is there, that is of theta plus phi. So as we got theta is equal to 60 here, complete projection is there. So theta plus phi is how much it is? Theta plus phi is what here? 90 degree. Look at it. This from this to this it is. Right? So theta we got it here 60 degree. So 60 plus phi is equal to 90 degree. That means it is phi is equal to 30 degree. By calculation also, by seeing this method also, we'll get to know that phi is 30 degree. As soon as we got the phi is 30 degree, just put it in the final answer, that is of x is equal to a sine omega t plus pi by 6 it is. So that is of 30 degree means pi by 6. So this is the same answer. Look at here. This is also same answer we got it. Method of simplification through the simple harmonic motion and method of phasor diagram. So phasor diagram is a very smallest and very shortest method to find out the equation of particle of when it is in the simple harmonic motion. Now we have understood when it is moving towards the positive direction. It is also possible when it is moving towards the negative direction. Only thing that a sine omega t plus phi is there, no? In that you have to just subtract. So these things, yeah, anti-clockwise direction we will discuss in the later, because only once a time we have put it in our head, all the concept means it will get confused when that relevant problem will take, no, at that time we will discuss regarding towards the anti-clockwise direction. So until then you just prepare with the clockwise direction, that means particle is moving in a positive direction. So get practiced of a phasor diagram, it will be very helpful in solving the competitive problems. Within a 5 to 15 seconds you will solve the problem. Only thing that you need to get out, find out of the phi here. Once you got the theta value, you can easily frame the phi. So this method what I have discussed now here to find out the theta value, this you can do it in your mind. Very soon you will get the theta value. Then once you got the theta value, there is no much difficulty in finding the phi value. So once you got phi value, just to substitute in the general equation of particle executing simple harmonic motion, you will get it the solution of it. So this is about the phasor diagram, and will give one problem here that we will going to solve with the same phasor diagram only. I will just give it to you as a one of the work form it is. So you do it, try to do it. In the next class we will solve and go for the next topic of it. So if particle execute simple harmonic motion initially at x is equal to minus a by 2. So minus a by root 2. Let us change of it. So root 2 here, and initially it is moving in the positive x direction. Same problem it is. Find the equation for a particle x in simple harmonic motion. Same problem it is, but theta is moving initially negative here. So slight change is there. Put the phase diagram. I'll just give the hint to it, right? So put the phasor diagram here. So you need to try it, just you need to try it here. So particle is this is a clockwise direction. So you just take it as a x is equal to positive here, x is equal to negative here. This is nothing but 0. If you want more clarification, just write it here, x is equal to 0. Particle is moving in anti-clockwise direction. That means where it is moving in this direction, anti-clockwise. Here it is. So it is moving in this direction. So particle is there here, this in this form it is. So T is there here, this form. This is nothing but the phi here, right? It is moving certain distance, say about T it is. So this is the projection here. So you need to find out. So look at here, particle, I said it has to move from here to here it is. So this 90 is there here, this 90, right? That means complete pi it is next to this part. You need to find out this. So try among yourself. Then next, in the next upcoming classes, we'll discuss this problem and we'll go for the next concept of the same chapter.